Hello everyone and welcome back to my YouTube channel. So today's topic is about the most important practical questions of B Pharmacy semester 6 third year. So first of all, we'll begin with medicinal chemistry. One of the most important medicinal chemistry's practical is assay of isonic acid. So assay is basically determination of the percent purity, and mostly isonic acid is acid either by bromatometry or by iodometry. Majorly we use bromatometry method for isonic acid assay, and it is a first line drug for treatment of tuberculosis. It is a widely used anti-tubercular drug. Next we have the green chemistry synthesis. Why is it important? Because usually in laboratories there is a use of lot of chemicals and it takes a lot of time for refluxing. But while we are using green chemistry, it takes a shorter time for synthesis, and this phenytoin is a highly used anti-epileptic drug. So it can be used in convulsions, it can be used in seizures. In this green chemistry, we just have to remember the wavelength, the microwave irradiations, the importance, and how is green chemistry beneficial over the conventional method of synthesizing molecules. You mainly have to study the principle and the factor calculation for all the individual assays and synthesis. There are various syntheses like synthesis of hexamine, synthesis of chlorobutanol, synthesis of sulfanilamide, and there are various assays as well, like assay of dapsone, assay of metronidazole, assay of isonic acid. So you just have to remember the important principles and factors involved. And suppose if it's standardization, do you standardize it via help of a primary standard like potassium hydrogen phthalate? Or if it's a non-aqueous titration, you have to remember the type of titration, whether it's precipitation, complexometry, acid base, that neutralization, non-aqueous or aqueous. If it's non-aqueous, just remember that the leveling effect and the solvent used will be perchloric acid, which is prepared via glacial acetic acid and acetic anhydride, and some amount of perchloric acid. So just remember the importance of each and every assay and synthesis. It's very important to know the principle. And via the syllabus, you would come across few name reactions like Debes-Radé-Zewski reaction, that is involved in the synthesis of 2,4,5 triphenyl imidazole. Just remember, imidazole is a 5-membered ring with nitrogen at 1 and 3 position. So 2,4,5 triphenyl. This is the first position. This is the second position. This is the third position. This is the fourth. This is the fifth. So 2,4,5 triphenyl means just attach the 3 benzene rings. That's it at these positions. And just add on the double bonds. This is your 2,4,5 triphenyl imidazole that involves Debes-Radé-Zewski reaction. Pinacol-pinacolone rearrangement, it is usually in the phenytoin synthesis. Phenytoin is a 5,5 diphenyl hydantoin. Why is it called as a hydantoin? Because it consists of an imidazole ring with 2 keto groups, and these keto groups are further adjacent to 2 phenyl rings. This is the structure of phenytoin. It consists of 2 benzene rings, 2 ketone groups, and 2 iron imidazole rings. Peckman's reaction and Michael's 1,4 addition, they are also very important reaction that you can come across. So just don't forget these terms, these name reactions. Next we have pharmacology 3. You have to study about ANOVA, one-way ANOVA, two-way ANOVA, MANOVA, ANCOVA. There are different types of ANOVA. So ANOVA stands for analysis of variance. Analysis of variance. Next you have students test. Now students test is of 3 types: T test, Z test and F test. Sometimes ANOVA is also called as F test. T test basically involves sample either it involves sample of the same test, or it may involve different samples. And the population is quite small in T test. In Z test, this population can be a little much more better, and the variance is unknown. Next, we have main principle of a drug. Like, you just have to remember a few terms like what is synergism, that is 1 plus 1 is equal to 2. So it supports additive effect, that is also the additive effect. Supra-additive effect is potentiation, that is 1 plus 1 is equal to 3. It is additional benefit. Antagonist. Antagonist, you have to remember, are physiological receptor antagonist, physiological antagonist. But the most important are receptor, that is competitive and non-competitive. So just remember the difference between competitive and non-competitive antagonist. Competitive has a similar structure. It binds on the active site, and it can be reversed. But non-competitive, it cannot be reversed. Pyrogen testing, there are two methods: in vivo and in vitro. In vivo, majorly inside the body, we use rabbit method. In vitro, we use LAL test, Limulus amoebocyte lysate reagent test. LAL test. So you have to study about the rabbit. Also, there is a table that you will come across that if first you will take 3 rabbits, then you will take 3 plus 5. In 3, the individual rabbits, the temperature should be less than 0.6, and the sum of these 3 should be less than 1.4. If it's more than this or more than this, then we take 5 more rabbits. We see that the temperature is around 1.4, 0.6 of course individual, and 3.7 including all the 5 rabbits that are new and the 3 rabbits that are previous. So the sum, that is the 8 rabbits, the temperature should be less than 3.7 degrees, and if we are taking the previous one, it should be less than 1.4 degrees. Now, next we have to remember is anti-allergic activity by mast cell stabilization. So mast cell is basically useful, involved or activated and degranulated, we can say. They are degranulated and release inflammatory mediators. What do they release? They release inflammatory mediators. These inflammatory mediators include leukotrienes, histamines, prostaglandins. There are various inflammatory mediators. So degranulation of these mast cells is responsible for allergic responses, for inflammations. Study of anti-ulcer activity using pylorus rigans, that is the shy rat model, and NSAIDs. Just remember, whenever we consume NSAIDs, either aspirin, ibuprofen, mefenamic acid, phenylbutazone, they are capable of producing ulcers. Ulcers are basically erosion of your mucous membrane. Erosion of your mucous membrane, and it gets a little bit rough, red. There's a flare inside there, and it is also caused by H. pylori, which is a gram-negative bacteria. But we have to study the anti-ulcer activity. Then you have to know the formula for this anti-ulcer activity, and then you have to remember the markings given, like 0 is for no ulcer, 0.5 is for spot, 1.5 is for hemorrhagic, 2 is for deep, 3 is for red. So you just have to remember the what denotions, what number denotes what. Next, we have acute oral toxicity, skin irritation, and eye irritation. These are very, very, very essential for you to remember, because OECD guidelines are followed for carrying out toxicity studies and irritation studies. Irritation studies can be acute, subacute, chronic, subchronic, and the time duration varies. Like acute is approximately 24 hours, subchronic is around 28 days, subacute is around 28 days, subchronic is around 30 to 90 days, chronic is around more than 90 days. So just remember the days involved. And OECD guidelines, mainly 404 and 405, are involved in skin irritation. 404 and 405, skin irritation and eye irritation. Next we have HDT, that is the herbal drug technology. And this is the practical that involves total alkaloid, phenol and aldehyde content. So for phenol, remember that gallic acid equivalent method is used. The other name for the same is Folin-Katechu method. So don't remember this Folin-Katechu method and gallic acid method, because these two are very, very important for determining total phenolic content. So always remember these two terms. And next we have role of the ingredients used in cream. So whenever we are preparing a herbal formulation like a herbal cream, we use different phases like aqueous phase and oily phase. So the preservatives used are different. Like in aqueous phase, we use methyl paraben as preservative. But for oily phase, we use propyl paraben as preservative. Similarly, we use certain ingredients like cetostearyl alcohol, glycerine, stearic acid, which is a emollient also, triethanolamine. So we need to study the role. Where triethanolamine is basically pH stabilizer. Some are emollient action, some show emulsifying action, some are protective action. So the action depends upon the ingredients used. So you have to remember the role of ingredients used in the different cream and lotion. Just remember the herbal excipients as well, like acacia, agar, tragacan, suspending agents, coloring agents, flavoring agents, etc. Just remember a few examples. They could be asked in Viva. So that's all for today's video. I hope you enjoyed it. This is the mobile number. If you have any doubt, you can feel free to contact or you can mail me. This is my SlideShare account, the Instagram page. You can follow the page for more tips and tricks. This is our YouTube channel. So you can just follow, just click on it and just gain more knowledge. I hope this video helped you to understand more. Thank you so much for watching the video.